ଆମେ ପ୍ରେଜେଣ୍ଟ ଅଛୁ। ତ ହ୍ୟାଲୋ। ତ ପ୍ରେଜେଣ୍ଟ ଅଛନ୍ତି ମଧୁ ମ୍ୟାଡମ, ଚିନ୍ମୟୀ ମ୍ୟାଡମ, ସଙ୍ଗୀତା ମ୍ୟାଡମ। ଓକେ
Good
ଓକେ
evening,
ଓକେ
ma'am,
ରାଇଟ୍।
sir.
ହଁ,
Yes,
ଭେରି ଗୁଡ୍
good
ଇଭିନିଂ।
evening, ma'am.
ଭେରି ଗୁଡ୍ ଇଭିନିଂ। ଆଚ୍ଛା, କ୍ଲାସ ଆରମ୍ଭ କରିବା।
Yes, ma'am.
So basically, this class is about the basic of mathematics that will we utilize to understand the microeconomics or the other parts of the economics also. As we know nowadays, economics is not based on the theoretical aspect only. There's much more mathematics is used to understand it's a better way. Mostly, if I talk about the microeconomics, we have to understand basic mathematics, which include set theory, also include functions, derivative, integration, so many parts. So today class mainly focuses on understanding these mathematical applications. Okay, here it is mentioned that mostly what is a function, what is domain, what is range, how a function is noted, what is implicit function, explicit function, types of functions, so many things. Then when you apply calculus, then we can find optimizations of a variable. So today's outline is introduction to function. Then is domain and range. Then what is implicit function, explicit function, then function is divided on the basis of whether it is a linear function or non-linear function. Then we understand what is the slope of a function, how it is calculated using derivative. Then we comes what is curvature of a function, how it is used again using the method of second order derivative. After slope is over, come to the point what is elasticity, how it is calculated and how it is related to slope. Then optimization of a variable, maybe maximization or minimization. Its application will be shows what is Euler theorem, which is otherwise known as product exhaustion theorem. What is homogeneous function, homothetic function, so on. So here we start with what is a function. So a function of a real variable x with domain D is an algebraic rule that assigns particular value of y for the given value of x. It means suppose you have a generally we write how a function is notation. Function is written in this way. We write okay, y as a function of x, right? In this function we read it y as a function of x or y is f of x. Here x is known as our independent variable because x can take any value. Then y is known as dependent variable. Here, as the name suggests, y cannot take any arbitrary values. Its value will depend on what value of x you have chosen. That's why we say y is a dependent variable. So here this f is the rule that combines y with x. When you for the given value of x is put in this function f, then it will be given as an outcome, it will give another value of y. All the possible of value of y that we can get for the given values of x. They have to calculate it. In this condition, what is domain? Domain is the possible values of that x can take. And what is y? For that possible values of x, although output the values will get, the output will get is known as range of the function. Here. So, as we say, a function is a relationship between two variables. In this case, two variables. There can exist relationship between many variables. Maybe our dependent variable is always, most of the time, it's unique, single. But independent variable can be many variable. It is a one independent variable, but that can be many variable. Like we say, y is a function of both x1 and x2 and xn up to xn. It's a multi-variable function every input, yeah, but here the actually you see when the this f what is the combines the rule, it gives for the given value of x, it gives a value of y. If the value of y which we get is unique, then only we say it is a function. So suppose for the given value of x equal to 5, we get y equal to 2 and 3 or 4, maybe three values. In this condition, we cannot say y is a function. That is terminology. In that condition, we say y is a mapping. If the depend for given value of independent variable, the dependent value gets a only single value, we say that is a function. If for the given value of a independent variable, the dependent variable is getting many values, then we call it a mapping. Okay. And mapping We are not using the concept of mapping in economics mostly till now. In advanced economics, we may use mapping in place of function. Okay. Then comes some examples, real life example. Your height is a function of your age. As you getting more older and older, your height is increasing. After certain stage, why your height remains constant? So it is we say that our height depends on our age. The age is my independent variable, and my height is my dependent variable. And similarly, temperature is a function of time during the day. As time changes, its temperature also changes, and so on. Then similarly, you can say your exam score. Your exam score depends on your how many hours you study. In this case, your independent variable is a single variable, that is the how many hours you study. But how much you score may also depends on your IQ level, may also depends on how much material you have. In this condition, now the independent variable are many variables. Okay, then comes the standard notation, how the function is written. In this in this case, you say y is a function of x. That means in the left side, we always put our dependent variable. In the right side, we always put our independent variable. In the first category, we say y as a function of x. It is clear that y depends, y is the dependent variable and x is the independent variable. Its inverse function is written as a function of y. That means in this case, x is the dependent variable and y is the independent variable. Yeah. Both the first y is f of x, and its reverse function or inverse function is known as x as a function of y. Look here. Your f is a functional notation, but in this case, second case, g is a functional notation. Why the functional notation changes? Because the rule binding x and y in first case will be different from the rule that is combining x with y in the second case. Is this clear? Madhu ma'am or Sangeeta ma'am, can you
Ma'am,
please also,
can you
madam,
again repeat why the functional form
notation
is
is
changes?
different. Okay,
Yes, yes.
okay, ma'am. Okay, okay. Suppose in the first case, I write y here. Y is equal to x square, right? What is the rule here? Here the rule is, the f rule is the square, taking square of independent variable, right? It is the y as a function of x. But if I write the inverse function, where what is the value of x? Now x will be half root over of y. Clear? What is the rule here? Your g is square root. The rule that binding y and x is square root. See, in the first case, the rule is squaring the independent variable. In the second case, the rule is take the square root of the independent variable. The rule differs. That's why our functional notation also differs. In the first case, we say y is f of x. Y is, sorry, f of x. In the second case, we say x is g of y. Is it clear?
Yes, ma'am.
Okay. Okay, so what is dependent variable, independent variable, it is clear. Then we can go to next slide. Okay. That is function, and is we can find many type of function in economics. Most popular is the demand function, and the others are supply function, as you say, consumption function, production function. In this case, let's see, take example of demand function, where you say QD is the quantity demand, is a function of price. So in this case, my quantity demand is a dependent variable and P price is the independent variable. Clear? When you go ahead of this class, then we'll study the types of functions. So there we'll study why it is a linear function or cubic function. But now we'll just distinguish between what is dependent variable, independent variable. So someone if you say we are dealing with a demand function, so your mind should say that in my quantity demand is the dependent variable and price is the independent variable. When someone say we are dealing with the supply function, then you should think that quantity supply is the dependent variable and price is the independent variable. Similarly, I think you can easily understand this. There's nothing to explain here. Then comes take example of what is the consumption function. That most important function in macroeconomics. What you write now, C is the what is C? C is the consumption. That depends on what? Now Y. What is Y? Now level of income. So from this two is clear. What is my independent variable here is Can anyone say what is my independent variable?
Y.
Y is my independent variable. And what is my dependent variable?
C.
C.
T is my dependent variable. Look here, my dependent variable is mentioned in the right side. In this equation, the right side of the equality sign is my dependent variable. In the left side, we put independent variable. It is a general notation. It doesn't mean that if we change it, it will not change our interpretation. Generally, we're writing in this way. Now, third question is, what does function tell us about? It simply say that my consumption, how much I consume, that depends on what is my income level. Simple. This dependent and independent variable says. Clear? Next, look here. What are the other value? This 50 is a constant. 0.75 is a constant. What is this 50? And 0.75 explains here. As we know, in the macroeconomic class, we know that this 50 will be termed as autonomous consumption. Autonomous consumption. That means whatever may be my income may be 0, but still I will consume something that is equal to 50 units. How will get it my autonomous consumption? When you put y equal to 0, it is clear. By definition of autonomous consumption is when y equal to 0, when income is nothing, nil, 0. The amount I will consume is my autonomous consumption. So mathematically, how I will calculate it? Here in this next part, look, put y value y equal to 0, what will get the value for c? C is equal to 50 plus 0.75 into y. So y equal to 0, the consumption will be 50 plus 0.75 into y is equal to 0 is value equal to 50. So it is clear that if my income equal to 0, my consumption is 50. Hence it is clear that my autonomous consumption is 50. Now, when y equal to 100, what is the value of c? Similarly, you can put c is equal to 50 plus 0.75 into y, that is equal to 50 plus 0.75 into value of y equal to 100. If we do it, we'll get 50 plus 75, that is equal to 1 to 5. Clear?
Yes, ma'am.
Now look at the third question. It says for every 1 rupee increase in income, how much my consumption will increase? So what is ask? How will you know from this function that y equal to 50 plus 0.75y? To get its answer, we have to use a tool that is we call as slope of a function. And how a slope of a function is calculated? By taking the first order derivative. So the answer will be delta C due to dy. The change in consumption due to change in income. So that means we have to take the first order derivative of the consumption function. In place of C, I can write 50 plus 0.75y with respect to y. So 50 derivative will be 0 as it's a constant term. Then derivative of 0.75 into y equal to 0.75. So what is this dc upon dy says? If my income is changed by 1 unit, then my consumption will be increased by 75 unit, 0.75 unit. That means if my income is increased by 1 rupee, so my consumption will be increased by 75 paisa. So this constant 0.75 near the value of y is known as slope of the function. In economics, we say what is this term is known as marginal propensity to consume. What is the definition? If we change our income 1 rupees, how much will dedicate for consumption? The answer is 75 paisa. Clear? Okay, then go to next slide. Okay, now just a minute, I have to delete it. Yeah. Okay, now check another consumption function. Okay, it is clear, dependent variable, what is independent variable. All these things are clear. We get the answer also. How to define a function? It's a definition. If y is a function of x, what is a domain? So what is domain? The set of all possible values that x, or the here x is my independent variable, but my independent variable can take. We says that is domain. And what is range? For the given the value of those x value, given the values of my independent variable, all the possible values of y I will get is known as range of the function. If you take an example, suppose I'm taking an example. Yeah. In economics, we write what output, let output depends on labor only. Yeah. So what is the possible value of labor will be? We know in economics, labor, the labor hour cannot be measured in negative numbers. It can be measured in positive numbers. The labor hours, what is the domain of the function here will be 0 to positive infinity. Clear? That may be 0, 1, 2, 3, any positive number. Negative number cannot be my domain because labor unit cannot be measured in negative terms. So all the possible values, any positive value can labor take. That's why this is my domain. So what is the range? If we put any positive value to the function, all the possible value of q that I will get. If the functional notation is mentioned in this way, q equal to, that here, q equal to 50 plus 20L. In this case, L can take minimum value, can take 0. What is the minimum value of q will be? 50 plus 20 into 0, that is equal to 50. Now, when L, it is clear that it's a positive sign indicate if L is increasing, q will definitely increase. So value of q, the minimum it will take 50, then it will go on increasing. Along with that, if it's mentioned that my capacity maximum labor I can utilize equal to 100, in that condition, what is the maximum of output? Q will be 50 plus 20 into 100. Just a minute. How to minimize this? Okay. Minimize this. That is equal to 20 into 100. That is equal to 50 plus 20 into 100 equal to 2000. That equal to 2050. So what is the range? Range of the function will be starting from 52 up to how much? 2050. This is my range of the function. Okay. Okay. I hope this function is clear. We'll go to next slide. Then comes, suppose your function is given, you have to find out its domain and range. Suppose y equal to 2L plus 1. So where L represents labor unit and L is greater than equal to 0. It is clear that labor can take the positive values. So domain of the function will be 0, 1, 2, 3, 4, 5 up to how much units of labor I can utilize. I can utilize infinity number, maybe 20, 30. It is clear that the positive natural number is my domain. So what is my range here will be? Can anyone say what is the minimum value of the range will be? In this function, y equal to 12 plus 1. What is the minimum value of the range?
Ma'am,
Ma'am,
1.
1.
Then it will go on increasing. It like 1, then second comes up 2 and 3, then comes 5, so on. So we can calculate domain and range. There will be no issue. Okay, it is mentioned here. So how to write it? This L belongs to 0 to infinity. Look at 0, that is the bracket, the square bracket is known as, this is called as close bracket. That means in the domain 0 is included. But at the right side of the infinity, there is the bracket, this bracket is known as open bracket. It's open bracket. It means the infinity is not included because natural thing, the value of infinity is not known. Next comes, why domain restriction matter in economics? Because most of the economic variable can be measured in positive numbers. Like we cannot measure output in negative numbers. That is meaningless to say that I have produced or minus 100 units of output or minus 30 units of output. Output can be measured in only in positive number. In my labor, capital, or the number of goods I am consuming, the number of money I have, all that variable can be measured in positive numbers. That's why domain is restricted. Restricted that it is only positive number can be taken. Again, it is the minimum. Suppose the producer is producing something, but due to some restriction, per day he can produce only this amount of output. Suppose like for government restriction is that you cannot use more than 1,000 units of raw material in a day of production. In that condition, what is my constant? My domain, the maximum output I can produce is restricted by my labor that I can use. That's why there is a constraint. The domain is constrained by lower limit as well as by the upper limit. Similarly, suppose I am using labor which is measured in terms of hour of a day. A particular labor can work maximum of 24 hours because there is one day is maximum of hour is 24 or minimum hour is 0. That's why there is a restriction. That's why domain is always constrained. Yeah. Similar to mathematical requirements, we have to constrain the domain. Suppose a function, suppose output q equal to root over of L or x. X is the labor. We know root over of negative number is not possible. That's why we restricted the domain as x is a positive number and so on. Again, square root of positive number is possible. So in this condition, we say that f of x equal to x minus 2 root over. In this condition, if we take the value of x equal to 0, what is the value of y? Equal to minus 2 square root, which is impossible. So we have to make the restriction that minimum value x can take equal to 2. So that 2 minus 2 equal to 0, the square root is possible. When we increase the value of x, we get a positive number, square root is possible. That's why domain is restricted here. Similarly, in this function, f of x equal to 1 by x minus 3. We know if value of x equal to 3, then y will be 1 by 0, which is undefined. So not possible, we cannot define the function. That's why in this case, what is the possible values of x will be? All the value except x equal to 3. So how to write it? The domain equal to open bracket minus infinity to 3. That means you can take any negative number which is less than 3. Then included 3 to infinity. That means take any value which is 3. Listen, in this case, 3 and minus. Actually, in this part, the minus infinity to 3 union 3 to infinity simply indicate minus infinity to plus infinity. That is a real number. Minus 3. It should be written. The real number minus 3. The number line, we can take all the value except x equal to 3. Yeah. Then, in this case, find the domain and range of the following function. Can anyone please say what is the domain of the first function? F of x equal to x square minus 4. What is the domain of this function? So what is the possible values x can take? Here x can take any value. No restriction is there. This domain will be minus infinity to plus infinity. How to write it? This domain equal to minus infinity to plus infinity. X can take any value. But what is the range of the function? See, when you take, suppose it is maximum, let you take it 0, x value equal to 0, y value equal to minus 4. When you increase by plus 1 or take it plus 1 or minus 1, answer will be same. Because plus or minus 1 maybe, the square become 1, so 1 minus 4 equal to, it becomes minus 3. If you take 2 or minus 2, the square become 4, so 4 minus 4 equal to 0. So that means its minimum value will be 4 range. Then maximum value goes on increasing infinity. So in this case, range will be minus 4 to positive infinity. Clear? Okay. Then I think other function, domain and range, you can calculate, estimate. It's not a big issue. Then let's go to second slide. Next slide. Okay. Total, it's application. cost function. Given the total cost function, TC equal to 50 plus 10Q. Where TC is my total cost, Q is the quantity of output produced. So, you see that pump's capacity is given 100 units. So, find domain and range. So, in this condition, what is the domain? Take example, what is the domain of this function? We say D, domain. What is the value of labor? The output we produce measured in positive number. So minimum of the value of Q will be definitely 0, right? We cannot use negative of the quantity of output we produce. The minimum value of Q equal to 0. What is the maximum of output we can produce? It is given that our maximum capacity equal to 100 units. So what is, so if I produce 100 units of output, the maximum cost I will incur equal to 1050, because put the value of Q here, is equal to 50 plus 10 into Q is 100. That is equal to 50 plus 1000. That is equal to 1050. The maximum value the total cost can take is equal to 1050. This is my domain. Sorry, this is my range, not domain. This is the range of the function, because the possible value EC can take from 0 to 1050. This is my range. So what is the domain equal to? 0 to up to how much? Na? Maximum capacity equal to 100. This is my domain, 0 to 100, and range is 0 to 1050. Then go to next slide. Okay, am I audible to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Then again, function can be written either in an explicit format or in an implicit format. So what is explicit format or implicit format? Explicit means when a function, that is, we write in this format, y is a function of x, or y is equal to f of x. Where in this case, one side you will have your dependent variable, and other side will have all your independent variable. That is, my dependent variable y is explicitly explained, or explicitly used as a function of my independent variables. That's why it is called an explicit function. In the similar case, x is a function of g of y. For example, take some example. Here, y equal to 3x plus 5. Here, y is explicitly represented as, it is a 3 times of x plus 5. That's why you call it explicit function. It is used, y is represented in terms of x. Explicit, there is no more combination of yx is there. Similarly, y equal to x square minus 4x plus 7. It is also explicit function, and y is represented in a function of form of x only, and so on, these variables. So how to remember, how to know whether this is explicit format or implicit format? Remember, in the left side, in general cases, we write our dependent variable. And the right side of the equality sign, we will write your independent variable. In the all the above example, 1 to 4 example, you mention left side is only one variable, right side is another variable. So it is clear that this is the explicit function. So what is implicit function? When x and y, dependent independent variable, are mentioned together. In this condition, in this example, look, 4x plus 3y minus 12 equal to 0. In the left side of the equation, both dependent variable is there, independent variable is there. So y is not explicitly represented in terms of x. Rather, they are combined represented in a functional format. So that's why it is an implicit function. Similar in the second example, in the left side, we look both dependent variable and independent variable. Similarly, all other example. So I think it is a minor thing. We can understand what is, whether the function is explicit format or implicit format. There's nothing to worry. Go to second. But how to convert? Suppose in this example, given your implicit function 4x minus plus 3y minus 2l equal to 0. We have to find the explicit function. That means we have to put dependent variable in the left side and independent variable in the right side. Now, there's a question arises, which one is my dependent variable? Which one is my independent variable? Two cases will arise if I take y as my dependent variable. So in this case, we'll get, right, what is the value given? I have to find out y as a function of x. In this condition, y is my dependent variable, x is my independent variable. This is completely so that this is in explicit format. Y is explicitly represented in terms of x. This will be called as explicit function. What is the value of y in terms of x will be then? We have 4x plus 3y minus 12 equal to 0. That implies we keep y one side, the term having y is 3y in one side, and take other term to opposite side of the equality sign. So it becomes plus 12 and minus 4x. Now that means y becomes 4 minus 12 minus 14x divided by 3, that is equal to 4 minus 4 by 3x. So this is the implicit format, sorry, explicit format. Y is explicitly represented in the form of x. In this condition, y is my dependent variable, x is my independent variable. Second, if I take x is my dependent variable, so my function will be x, will be suppose function of y. In the left side, I'll put x, and the right side, I'll put y. How to do it? Now, suppose given that 4x plus 3y minus 12 equal to 0, put the term having the x term. This is 4x, this term having x, so put it one side and take others to opposite side, 12 minus 3y. So that implies what is x? X equal to 12 minus 3y divided by 4, that is equal to 3 minus 3 by 4 times of y. It is clearly mentioned that x is clearly explicitly represented in terms of y. So it become a explicit function. So we can say that from one implicit function, we can find two explicit functions. Take one, x is dependent variable, and in this case x, y as dependent variable. It will be over. Then goes to next slide. Okay. Solution. The same thing we explain here. So nothing to explain. Then theorem. There's a great, this is important theorem when we have to, when we use to find out derivative. The theorem said that we have, suppose given the function, we have y as a function of x. Y as a function of x. So we can easily find dy upon dx simply in place of y, putting the value of x. You can find out. But if it asks you that find out dx upon dy, how will do? First of all, what we have to do? We have to convert it x as a function of, suppose y, we have to convert it. Then we'll take the derivative of this variable with respect to y. Then we'll find derivative of x with respect to y. How? Now derivative of f of y with respect to y. To find dx upon dy, we have to find out this format, this explicit format where x is my dependent variable. But without getting this, I can, without converting the functional notation in terms of y as f of x, we do not need to represent it in terms of x as f of y. So what is the method I have to use? Suppose given my dy upon dx, so what is the value of dx upon dy? You simply will be take its reciprocal 1 by dy upon dx. This is the formula. Derivative of dx upon dy is the reciprocal of derivative of dy upon dx. When we cross multiply it, we get the theorem that is dx upon dy into dy upon dx is equal to 1. So here in this condition, I write that y as a function of x is the function. So x as a function of y become my inverse function. So we have to find out derivative of dx upon dy. We do not need to find out the inverse function. Simply put the theorem. Okay. Then suppose we have to check this theorem. Given the function y d 4x plus 3y minus 12 equal to 0. You can find y as a dependent variable and its function, then take its derivative. So y will be becomes minus 4 by 3x plus 4. So derivative will be dy upon dx will be minus 4 by 3. Similarly, from this, the given function 4x plus 3y minus 12, we find out x as a function of y, that is equal to x equal to minus 3y, 3 by 4y and plus 3. Derivative will be minus 3 by 4. Now cross multiply it. Answer is 1. So the function, the theorem is proved. Nothing to worry. Before is why the slide is not moving. Okay. Then comes market equilibrium condition. Look, in this condition, the demand function, quantity demand equal to 100 minus 2p. It is a explicit function or implicit function. In this function, it is clearly stated that p is my independent variable, quantity demand is my dependent variable. And the dependent variable is explicitly represented with a function of p. It is clear that this my demand function will be a which format? In the explicit format. Similarly, supply function is in the explicit format. But the equilibrium condition require the quantity demand equal to quantity supply. Solving it will get a implicit equation. 100 minus 2p equal to 20 plus 3p. That you can say that is equal to 120 plus p equal to 0. This is in the implicit format. Okay. Quantity demand is a function of price, is my demand function. What is my inverse demand function? Price as a function of quantity demand. That is mentioned here. This is the inverse demand function. Why? In the inverse demand function, my price become my dependent variable. Quantity demand is my independent variable. Okay. Just remember, is quantity demand function of price, that is my demand function. But price function of quantity demand, that is my inverse demand function. Similarly, we'll interpret inverse supply function. Okay. Implicit differentiation. The same thing I say, given the function x cube plus y cube equal to 6xy. It is an implicit format. So differentiate both sides. So we have to find out dy upon dx. That means differentiate both sides with respect to x. If we have to find out dx upon dy, differentiate both sides with respect to y. I'm doing one example, we will find out other. In this format, it is given that let x cube plus y cube equal to 6xy. If I have to find out dx upon dy, so that means what we have to do to find out dx upon dy, we have to take a derivative of both sides, derivative of both side with respect to what? It is dx upon dy. Then the denominator, it is derivative of y. So take the derivative with respect to y. So we'll get derivative of x cube plus y cube with respect to y. That is equal to derivative of 6xy with respect to y. Okay. So it will be, when I'm taking the derivative with respect to y, so what will I do? I'll treat x as constant term. So I'll write derivative x cube, derivative becomes 0. The derivative of y cube will be 3y. So this derivative of x cube plus y cube with respect to y become 3y. That is equal to derivative of 6xy. So 6 constant, x constant taken outside. The derivative of y with respect to y will be 1. So that implies I will get. So one thing is wrong. Something, okay. I did a mistake here. So let me do it again. Given here, x cube plus y cube equal to 6xy. So I have to take the derivative of both sides with respect to y. As I have to find out dx upon dy, so take the derivative of both sides with respect to y. So derivative of x cube plus y cube with respect to y, and this side also derivative of 6xy with respect to y also. In this condition, we said derivative of x cube plus y cube. Take its derivative. It will be like derivative of x cube with respect to y. First, I have to find out derivative of x cube with respect to y. Then I have to find out derivative of y cube with respect to y. And this side derivative of 6 can be taken outside. You can say 6x can be taken outside easily. Is it visible to everyone?
Yes,
Hello?
ma'am.
Yes, ma'am,
Do you
yes.
understand what am I writing?
Yes, sir. Yes, ma'am.
Yes, ma'am.
Okay, okay, okay. Then takes I have to do derivative taken. Totally, I'm finding a little bit difficult in writing here. So can I do one thing? I'll omit it right now. I'll explain it in the maybe in the tomorrow class. I'm skipping this. How to get the derivative of dy upon dx? Then I'll have to find out dx upon dy. Can I skip it in today's class?
Yes, ma'am.
Okay, ma'am. No issue. We can
Okay.
continue.
Okay. But I'll explain it. I'll explain it. Why it is not moving here? Why it is mentioned here? Okay, I am skipping it. Okay. I'll explain it later. Okay, implicity, explicit function. The rule is used here, dy upon dx. I'll explain you how to find the derivative of implicit function. Let's keep it for now. Look the types of function. Here is a linear function. What is a linear function? A function where my independent variable or dependent variable that highest power is equal to 1. Then I say the function is a linear function. And this is written in the general form equal to y, which is equal to f of x. So that is equal to mx plus c. Here, m is known as slope of the function and c is the constant term, also known as y-intercept or vertical axis intercept. Okay. And the degree of the function is, what is the highest power of the variable? The variable is y and x. What is my independent variable x? It's our highest power equal to 1. The degree of the function is equal to 1. So it is a linear function. Example is the consumption function. Here the consumption function c is equal to c bar plus cy, small cy. In this function, this c is my consumption. Either this consumption is my dependent variable, and this y is my independent variable. Now, of course, what is this c bar? This C bar is known as in economics term, or suppose in mathematical term, we say that C bar, this constant, and the constant is known as y-axis intercept. This C bar is known as, in mathematics, we call this y-axis intercept. In economics, in consumption function, we say it is our autonomous consumption. Okay. Now, what is this small c? This small c in math is known as slope of the function. But in economics, we say it is a marginal propensity to consume. Take the example, suppose c equal to 100 plus 0.8y. Here, what we can say about this function? This is clear that y is my income, which is an independent variable, and c, the consumption is the dependent variable. At the highest power of y equal to 1, I'll say that it is a linear function. Now, the constant of this function are 100 and 0.8. So, how to interpret it? Here, the 100 is my autonomous consumption. The consumption, that part of the consumption which is free from income. That means if my income is 0, still I will consume that part. How to get it? Put the value of y equal to 0. We get c equal to 100 plus 0.8 into 0. That is equal to c equal to 100. This 100 become my autonomous consumption. This 100 is my autonomous consumption, and this 0.8 is my slope, or we call it marginal propensity to consume. What is this interpretation? In economic interpretation, how marginal propensity to consume is defined? That is like this. If my income is increased by 1 rupee, how much my consumption will increase? That is my MPC. What is MPC? 0.8. That means if income is increased by 1 rupee, my consumption will increase by 80 paisa. This is the interpretation of slope in consumption function. For different economic function, we interpret a slope differently. We have separate names for that. Okay. Now, some common linear function. Quantity demand as a function of price. Here, look, it is clear that P is my, what's called as independent variable. Here, P is independent variable. Quantity demand is dependent variable. A is the constant, or y-axis intercept. And what is B? B is known as slope of demand function. What is indicate? The slope indicate that if price is increased by 1 unit, to what extent my quantity demand will what year increase or decrease? As you know, it's a demand function, we can easily say the price increases, demand will decrease. But if it's not mentioned that it's demand function, how do you know? Look at the sign. The sign is negative. That means if price increases, quantity demand will fall. So how to interpret this slope? That if price increases by 1 unit, then quantity demand will fall by B unit. Okay. In this example, second example, quantity demand equal to 100 minus 2p. If I say price increase by 1 unit, then what will happen to quantity demand? The answer is it is declined by 2 unit. Second is our linear supply function. Similarly, we interpret the slope of the function. What is indicate? If price of the commodity increase by 1 unit, then its quantity supply will increase by D unit. Another linear function is total cost function. That is the fixed cost plus variable cost into quantity. Fixed cost is a constant number, that is 100 is my fixed cost, and variable cost equal to 20q. As the highest power of q equal to 1. So I say that this is a linear function. What is a non-linear function? Where the degree of the independent variable is not equal to 1. That become a non-linear function. In the first quadratic equation, the degree equal to 2. In a cubic equation, is highest degree equal to 3. Look at the highest degree. In different term, for example, in the quadratic equation, ax square her power is 2, but whereas bx power is 1. So we'll not the minimum power, we'll look at the maximum power. That become the degree of the power, degree of this equation. Your maximum power is 2. This is known as quadratic function. If maximum power equal to 3, we call it cubic function. With e to the power something, it is called an exponential function. What is hyperbolic function? Here y equal to a by x. That means when the multiply x into y, we'll get a constant number. That is the definition of hyperbolic function. What is the application in what type of function we can say in economics will be a hyperbolic function? The best example will be average fixed cost. That is equal to total fixed cost by Q. When multiply AFC into Q, we'll get TFC. So for different value of AFC and corresponding Q, when we multiply, we'll get a constant value because total fixed cost is constant. So that's why we'll say that AFC is a hyperbolic function. Then this is logarithm function and the power function. Yes, this is done. Next. Okay, some examples, graphs, quadratic function, cubic function. This is hyperbolic function, we can write this is average fixed cost curve, is diagram, or you can say it is a demand function where elasticity equal to 1. In generally, we write it is a downward rolling straight line. If it is not a straight line, it is in a cube, suppose quadratic format, it will be hyperbolic format. Okay. Then exponential function, logarithm function, parabolic function, which I take U shape or inverted U shape. These are the parabolic function. Given the total cost function, we say it is a quadratic function because highest power equal to 2. What is marginal cost? Is highest power equal to 1. So we say it is a linear function. But average cost function, it is highest power is not 1. Listen, q to the power 1, but here q to the power minus 1. In this condition, if power is not equal to 1, it becomes a non-linear. Okay. And the average cost function, this type of cost function is known as, it is not hyperbolic function, it is known as a parabolic function. So that is our U shape or inverted U shape. It is similar kind of function. Then some special non-linear, this is okay. This is the average fixed cost or demand curve with elasticity equal to 1. Multiply the variable that is P into Q, will get a constant term. It's called as rectangular hyperbola. This diagram, this graph is called as rectangular hyperbola. That means in the y-axis, it will not touch 0. In the x-axis, it will not touch to 0. But it will be more as goes on increasing value of Q or P. A value of Q, we find the curve is not very near to my vertical axis and my horizontal axis. But it will never cross anyone. And the important non-linear function that we use in production is known as Cobb-Douglas production function. Why? Because what is the highest power here? Here highest power is not alpha nor beta. Highest power equal to alpha plus beta. If alpha plus beta, here Q is my what is called a dependent variable, capital F or a independent variable. It is an example where we have many independent variables, right? So A is the constant and K is the capital, L is the labor and alpha and beta consider the output elasticity, or if output elasticity, as we interpret elasticity here, in the similar manner, we can interpret alpha beta. If the value of alpha plus beta equal to 1, we say it is constant return to scale. That means if we increase capital and labor by a given time, output will increase by the same time. That's why definition is constant return to scale. How to know? Just add the value of alpha beta. If the summation of alpha beta greater than 1, we say it is increasing return to scale. If less than 1, we say it is decreasing return to scale. And this condition alpha 0.3, beta 0.7, add it will get 1. That means it is constant return to scale. Now here we have to identify the function. Y equal to 5x minus y. So it is a linear function because highest power equal to 1. Second, here highest power equal to 2, so this is a quadratic function. The third, here, look, it is a rectangular hyperbola shape. Why? Because when you multiply y and x, it will give equal to 10, that is constant. So this function is rectangular hyperbola. 4, total cost equal to 100 plus 50q. It is a linear function. Your total output is a Cobb-Douglas format. It is not a linear, non-linear function. Secondly, this p equal to, this is also a linear function. Clear? I think there will be no difficulty in find out whether linear or non-linear function. Let's go to next slide. Slope. Slope of given a function, how to find out its slope? Slope simply is known as first order derivative of the function. You know the slope. If y is a function of x, then dy upon dx is known as slope of the function. In the geometry, how to find out the slope? Here, take any 2 points. Let the point be in this point will be known as point A, and this point will be known as point B. When you move from B to A, so how much change in y? That is equal to, suppose this is O, change in y will be OA divided by how much change in x occurs? That is BO divided by B or OB. Whatever you can write. So this is the slope. What is the value? Look, in the triangle ABO, it is a right angle triangle. Clear? Because O angle is 90 degree, is a right angle triangle. So AO is known as the perpendicular. BO is known as the base. Perpendicular by base is equal to, in trigonometry, it is known as tan theta. Given the angle theta, is take a tan value, that will be your slope. Basically, in economics, we are not using sine, cosine, tan. So hopefully you don't need it. It is completely utilized in maths. Then given the linear function, y equal to minus 4 by 3x plus 4. So what is the slope? Find dy upon dx. Find dy upon dx, the value will be minus 4 by 3. So it's a slope equal to minus 4 by 3. How to interpret it? If x is increased by 1 unit, then y will decrease by 4 by 3, that is equal to 1.33 unit. This is the interpretation. It is m equal to c, that is in the general format to be right now, y equal to mx plus c. Then compare it, the constant term c is equal to 4 and slope m equal to minus 4 by 3. X derivative minus 4 by 3. So slope equal to minus 4 by 3. Same thing, if you say that if x increased by 3 unit, y will decrease by 4 unit. Or I can say if x increased by 1 unit, then y will be decreased by 4 by 3 unit. Both are same thing. Yeah. Sign of the slope. If slope give you a positive sign, so we say that There's a direct relationship between two variable, dependent variable, independent variable. That means if one variable increases, another variable also increases. If one variable decreases, another variable is also decreases. And if slope faster derivative is less than zero, that means there is opposite relation or inverse relationship between two variable. That is, if x increase, then y will decrease, and vice versa. But what happens if slope equal to zero? That is dy upon dx equal to zero. Generally, we say there is no relationship between x and y. So this symbol is utilized. That means to find out the optimum value of the function. In this point, where faster derivative equal to zero, that means the function attains either maximum value or the minimum value. Here, it is a slope is positive, the increasing function. If the graph, it is a upward sloping line. If slope is negative, we get a downward sloping line. If slope equal to constant, we get a straight horizontal line, neither increasing nor decreasing. Then, slope is used to find out the marginal value of a function. If it's a cost, suppose cost function, that means we are given the total cost function. Take first order derivative of the total cost function, which says is marginal function. If it's a revenue function, that is total revenue function. If you take it first order derivative, the total changes to marginal. It's a revenue function, to become marginal function. So to first order derivative of any total function will give its marginal function. Okay. So first order derivative of the consumption function will be give you marginal propensity to consume. Given this TC, we can easily find first order derivative. That will give me marginal cost. Now, for the given value of Q, you can find out the specific value of MC. Just in the MC function, put the value of Q. You'll get what is the value of marginal cost. I think there is nothing to explain. Just look at here. I can say that the total cost function is a quadratic function, right? But look at the marginal cost function, it is a linear function. That means if the highest power of the total function is degree equal to n, so what is the degree of its marginal function? It is equal to n minus 1. If the total cost function is highest degree equal to 3, then its marginal function will be max degree equal to 2. If the total function has the highest degree 50, that's marginal function with the degree equal to 49. According to that. The constant slope. Again, now we know linear function. What is the difference between linear function using derivative? We know that derivative, first order derivative gives you slope. Okay? If it is a linear function, then its slope remains constant. In which point of the graph we find out its derivative, we will get the same value. First order derivative will give you the same value if it is a linear function. If it is not a linear function, a different point will find different value of its first order derivative. So how to interpret it? Derivative is known as rate of change. That means if x changes, to what rate y will change. In a linear function, if x increases by 1 unit, the y will change by same unit at any point of the linear function. If it's a non-linear function, the x increases by 1 unit at a point, then change in y will differ if we calculate it another point. For example, take it in this graph. Here, straight line, if we find out if A to B, to move from this point A to B, find out a slope. Similarly, move from B to C, find out a slope. Where A to B, next axis increase by 1 unit. Similarly, from B to C, in next axis we increase by 1 unit. The change in Y will be remain same in both cases. But if this is a quadratic equation, like suppose this, when you find a slope from this point A to B, it will give you a value. If you find out the slope from B to C, it will give you another value. In a linear function, slope remains constant throughout the graph. Non-linear function, it changes. Okay. Marginal MPL, the marginal product of labor. Okay, given my total product, to find out marginal product, we can easily find out taking first order derivative. So if you ask you for the given value of L equal to suppose 3, find out is marginal product, we can easily find for the value L equal to 3, we find it. The marginal product will be 59. Okay, here you see that MPL fast increases, reaches its maximum at L equal to 3. Here 40, 45, 48 goes on increasing, remains as optimum that is equal to 49, again goes on falling. So what type of shape will be? Shape will be the marginal product of labor will take in this shape. Past marginal product increases, then reaches its maximum, then declines. So what is this maximum point? Here, the value of L. This L is equal to 3. This is how the diagram will be taken. It is a inverted U shape or parabolic function. Okay, then go to next. Okay. I can find what is the slope here, y equal to 3x minus 7, here slope equal to 3. Second, in the total revenue, what is the slope? Take the first order derivative, that is equal to, can anyone say what is the first order derivative will be?
3.
Q minus 4Q.
What is the slope of total revenue? You cannot say what is the slope of total revenue because I have not specifically mentioned you what value of Q. So find MI. Slope is the marginal revenue. Slope, what is the slope? Slope will be, this is derivative of, okay, let me write it here. What is slope equal to? Which is derivative of total revenue with respect to Q. So what is in place of TR, I can write 100Q minus 2Q square. Look, this is not a linear function. The slope will not be constant. Its value will differ. So its value depends on at what value Q we are calculating. That is equal to, the partial derivative will be 100 minus 4Q. If I did not specify the value of Q, I cannot say what is the value of slope. If I say Q equal to 10, I can calculate slope equal to 60. If I say Q equal to 20, I will say slope equal to 100 minus 8 equal to 20. If it's a linear function, suppose TR equal to, this is TR equal to 100 minus Q. Okay, if I say what is the slope of the function, we do not need the value of Q because it is a linear function, its slope is constant, that is equal to 1. So whatever may be the value of Q, the slope equal to not 1, actually this is minus 1. In this, if it's a linear equation, we do not need the value of the independent variable. At every point of the independent variable, slope remains constant. If it is not a linear function, if somebody asks you what is the slope of the function, then you will ask, first of all, you say what is the value of the independent variable. At that point, slope will be this. Okay. Here you can verify, find, given this is the P as a function of Q. If it's demand function, then I say it is a inverse demand function because demand function always a quantity demand as a function of price. But here it is mentioned price as a function of quantity demand. So I say it is a inverse demand function. And this is in the completely explicit format because price is complete explained in terms of AQ. So it is in the explicit format. You can find dP upon dQ. What is the value of dP upon dQ? Here, dP upon dQ will be minus 0.5. Now I have to find out dQ upon dP. How to find out? First, find out the demand function from the inverse demand function. It is mentioned E equal to 50 minus 0.5Q. I can write 0.5Q is equal to 50 minus P. That implies Q equal to 50 minus P whole divided by 0.5. Okay, that is equal to 100. 50, sorry, that is equal to 50 by 0.5. 0.5 I can write is equal to half. So 50 minus P by half, I can say it is 50 minus P divided by half, I can say into 1 by half. Is it clear? Half, sorry, reverse. Multiply the divided by 1 by 2, then multiplied by 1 divided by 1 by 2. So that means it is multiplied by 2. Clear? It is a mistake that I did. That is equal to 100 minus 2 times of P. What is derivative? dq upon dp will be minus 2. So multiply dp upon dq is 0 minus 0.5 and dp upon dq equal to minus 2. Multiply it, we'll get the answer equal to 1. So verified? Oh, there's so much to go. What is curvature? Slope will give you, first order derivative will give you slope. That is the independent variable increases by 1 unit. To what extent dependent variable will increase? That is slope. So what is the curvature? It is otherwise known as slope of the slope. That means how the slope changes. If it's a constant linear function, the slope does not changes. So there will be no curvature for a linear function. If it's a non-linear function, that means at different point of the graph, slope will be different. So now we'll say how the slope is changing its value. That is known as curvature. How the curvature is calculated mathematically by taking the first order derivative. Yeah. Okay. And this mainly curvature function, the second order derivative mostly used to find out to check whether the function attains maxima or minima. And next diagram will say. Okay.
Madam,
Sir? Yes, sir.
if you are tired, we can stop over here. Tomorrow we can resume again.
Okay, sir. Okay, sir.
Because I
Okay,
think
thank you, sir.
already you have covered so much. So
Oh,
let us come tomorrow, and then they will also do the homework, and then we'll start again.
okay, sir. Okay.
Thank you, ma'am, for
Okay,
taking the
thank you.
session. Yes,
Thank you, ma'am.
I'm leaving here.
we'll stop over here, and we'll start from convexity and concavity. Even if tomorrow, ma'am, you can add also some like whatever you want to add extra, whatever it is not there in
Okay.
the slide also. Not a problem.
Okay, sir.
Okay, ma'am. Okay.
Okay, fine. Then, sir, I'm leaving. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.